All right, good morning, everyone. Welcome to another awesome e-learning day. Last class, we started out defining all of these words, rationalizing the denominator, meaning getting rid of the radical that's in the bottom of a fraction, like radicals with the same index. And remember, the conjugate from when we did complex conjugate just means you have two terms and you switch the sign between them. If it was something like 2 plus the square root of 4, it would now become 2 minus the square root of 4. We did this where we said if the index on each radical is the same, we can multiply the radicands. 2 times 8 would give us 16 and try and simplify it. These are both third roots, so the index is the same, so you can do 3 times 9 is 27, and then try to simplify that if we want. Then we went through some examples, worked this one out to be the square root of 25 is 5. We did 4 divided by the index of 2, gave us a squared. And then we had to do 9 divided by 2, which gave us 4, remainder 1. The 4 is the exponent outside of the radical. The remainder is the exponent under. And we did this example as well. Just more examples, practicing it. A fourth root. All right, this is the types of problems that we left off on, where we are trying to rationalize that denominator, get rid of any radicals down there. And our steps were to do whatever we can to make the denominator, remember it's all about the denominator, has to have a perfect nth root. So if the index is 5, it has to have a perfect fifth root. So you have to multiply both top and bottom by whatever is necessary to make the bottom have a perfect root. Once you've done that, then we simplify whatever we can. We did this problem here in class, and we left off, if I remember right, here. So we are working with a third root. Our index is 3, so we need to make sure that the bottom, 9x, we need to multiply it by something to make it have a perfect third root. So let's work on 9 first. The numbers that are perfect cubes, you could do 1 times 1 times 1 is 1. That's not going to be helpful though. So we need to go beyond 1. So 2 to the third power, 2 times 2 times 2 is 8. 3 to the third power is 27. And I'm going to stop there because I know that I can multiply 9 by something to get us to 27. And think, what is 9 times what gives us 27? Well, that's 3. All right. Now I have an x to the first power. I need to multiply x to the first power by something to make that exponent be divisible by 3. So that would be x squared, because x to the first times x squared would give us x cubed. So I'm going to multiply whatever you do to the bottom, you have to do the top as well. So I'm going to multiply top and bottom by the third root of 3x squared. If I do it to top and bottom, I haven't changed anything. Third root because it's third root here. 3 because 9 times 3 will give us 27, a perfect cube. And x squared because x times x is x to the third power, and 3 is divisible by 3. So now I do 2 times 3x squared. 2 times 3 is 6. X squared, I have the third root. In the bottom, 9 times 3 was 27. X times x squared is x cubed. And remember, the whole point is that this denominator is a perfect cube. The third root of 27 is 3. X to the third divided by 3. 3 divided by 3 is just x to the first, or just x. And the third root of 6, 6 can't be divided, or it's not a perfect cube, so 6 is stuck under the radical. If we do 2 divided by 3, you just get a 0 remainder 2. So the x squared is also stuck under the radical. But we have achieved our goal of making no radicals in the bottom of our fraction. So that's our answer, the third root of 6x squared over 3x. Right here, there's no index, so it's an invisible 2. So we need to make our denominator something that can be simplified by a square root. So we need this to be an exponent divisible by 2. 7 is not divisible by 2, but the next number up, 8, is. So I'm going to multiply top and bottom by the square root of y. Square root because it is started as a square root. Y to the 7th times y to the 1st will give us y to the 8th, and that is divisible by our index of 2. 8 divided by our index of 2 gives us y to the 4th on bottom. To simplify the top, we do 3 divided by our index. 3 divided by 2 gives us 1 with a remainder of 1, 1 remainder 1. So that means we have an x to the first, or just x in front of it, and then our remainder, x of 1, x to the first underneath, and then we still have y underneath as well, y to the first as well. So we have x square root of xy divided by y to the 4th, x square root of xy divided by y to the 4th. So C would be our answer. Here again, we need to get the denominator to be a perfect cube. 2 cubed is 8, 3 cubed is 27. I can't multiply 3 by anything to get to 8 very easily, but I can multiply 3 by 9 to get to 27. So I'm going to multiply top and bottom by the third root, because it's third root here, of 3 times 9 gives me 27, and my y squared I need a power divisible by 3, so y squared times y will be y to the third power. So that will give me, I have the third root of 27, y to the third power on bottom. And now here we can take the third root of 8. Third root of 8 is 2. Third root of 9, 9's not a perfect third root, so that's stuck under there, the 9. Y doesn't have a third root either, so y is stuck underneath. So the third root of 27 is 3. 3 divided by 3 is 1, so y to the first. So we have 3y in our denominator, so those are gone. We're down to just these two here. And we have 2 third root of 9y. 2 third root of 9, 2 third root of 9y. So C is our answer. All right, now we're going to work on this problem right here. This says 5 times the third root of 100a squared times the third root of 10a. Okay, so this is 5 times a third root times another third root. Since both of these radicals have the same index, they're both third roots, I can multiply their radicands together. So I have 5 times the third root of 100 times 10 is 1,000. A squared times a is a to the third. To find the third root of 1,000, since it has 3 zeros, that makes me think it is probably 10 to the third. 10, 100, 1,000. 10 to the third is 1,000. Third root of 1,000 is 10. So I have 5 times 10. Third root of a to the third, 3 divided by our index is 3, so just a. 5 times 10 is 50a. We can multiply the radicands because they have the same index. If they did not have the same index, if these weren't both third roots, we could not multiply the radicands like that. Same idea here again, third root, so we can multiply our radicands. 3 times 2 is 6. 16 times 4 is 64. And a squared times a is again a to the third. So I need to find the third root of 64. Remember, 2 cubed was 8. 3 cubed, we said, was 27. 4 cubed, 4 times 4 is 16. 16 times 4 is 64, and that's what I'm looking for right there. So the third root of 64 is 4. So I have 6 times 4. And then I do a to the third. 3 divided by our index of 3 just gives me a. 24a. B is our final answer. Again, it has to have the same index in order to be able to do that. Okay, now for adding and subtracting radicals. To add and subtract radicals, this is actually a little bit more difficult. We can't just go off of the index being the same, which is true here. These are all square roots. All of them have an index of 2. but we can't add them unless the radicands are the same. For adding and subtracting, the radicands need to be the same. The stuff under the square root needs to be the same to be able to add them. So let's see if we can simplify these at all to make them have the exact same radicand. So 45 can be broken apart to the square root of 9 times 5 minus 5. 80 divided by 5, because that's my non-perfect square, is 80 can be broken apart to 16 times 5. Plus 4, 20 can be broken apart to 4 times 5. The square root of 9 is 3. So we have 3 times 3 radical 5 minus 5 times the square root of 16 is 4 radical 5 plus 4 times the square root of 4 is 2 radical 5. 3 times 3 is 9 radical 5 minus 5 times 4 is 20 radical 5 plus 4 times 2 is 8 radical 5. And now we just add them up. 9 minus 20 plus 8 gives me negative 3 radical 5. Once you have them down to where the radicands are all the exact same number, you can almost think of it as like 9x minus 20x plus 8x, and just do 9 minus 20 plus 8 gives us the negative 3, and the radical 5 drops down. So to add and subtract, you have to have the same radicand. To multiply, you only need the same index. Right here, again, the square root of 75, I notice that that is 25 times 3 minus 2 times the square root of 48. 48 is 16 times 3 and plus the square root of 3. The square root of 25 is 5. Square root of 16 is 4. 3 times 5 is 15 radical 3. 2 times 4 is 8 radical 3 plus radical 3. 15, or I'm sorry, now that I have radicand, or square root of 3, square root 3, square root 3, they all have the same index and the same radicand, we can just add these up. 15 minus 8 is 7. 7 plus 1 is 8. So 8 radical 3. Now to multiply radicals, if you look, these are two terms right here. One term, two term, one term, two term. So these are both binomials. Just like when we've multiplied binomials in the past, that means we are going to FOIL. 2 radical 3 times 3. 2 times 3 is 6 radical 3. 2 radical 3 times negative radical 3. We have, it's going to be negative, so minus. And then we have 2 radicands can be multiplied. 3 times 3 is 9, so minus the square root of 9. Now we move on here, and we do plus 9. 3 times 3 is 9. Radical 5. And then we distribute here minus 3. Square root of 5 times square root of 3. Since they have the same index, we can multiply. 5 times 3 is 15. I have 6 radical 3. My square root of 9 is just 3. So minus 6. 2 times 3 is 6. Then I have plus 9 radical 5 minus 3 radical 15. These have the same index. They're all square roots. But to try to add them up, they would need to have the same radicand as well. This is a 3, that's a 5, and that's a 15. 3 has no perfect square factors, 5 has no perfect square factors, and 15 has no perfect square factors. So that's as far as we can take this one. That's our answer. If they wanted a decimal approximation, we could find out what 6 times the square root of 3 is in a calculator, round it off, and then subtract 6 from it, find out what this is, round it off, and add it, and then find out what this is as a decimal, round it off, and just add them all up. But if we want an exact answer, that's as far as we can go. All right, so same thing here. 2 rad 5 times 5. 2 times 5 is 10, the radical 5. 2 rad 5 times negative radical 7, we get a negative 2. 5 times 7 is 35. 35 has no perfect square factors, so that's not going to simplify. We do 4 rad 6 times 5. 4 times 5 is 20. Radical 6. 6 also has no perfect square factors, so that'll stay like it is. And then we have 4 rad 6 times negative, so negative 4. 6 times 7 is 42. So 10x rad 5 minus 2 rad 35 plus 20 rad 6 minus 4 rad 42. All right, here is our last example, and this is the one where we work with our conjugate. We work with the conjugate. So in order to be able to rationalize this denominator where it's a binomial, in order to get rid of that radical 3, we need to multiply top and bottom of this by the conjugate. So we are going to do x over x rad 3 plus x. We're going to multiply top and bottom by x rad 3 minus x, x rad 3 minus x. We multiply top and bottom by the conjugate of that denominator. Since this is a plus in between the two terms, we make it a minus in between the two terms. In the numerator, we just distribute our x. So we get x times x rad 3 is x squared radical 3. X times negative x is negative x squared. And that is all divided by, we FOIL this out, x squared radical 9 minus x squared radical 3 plus x squared radical 3, and that's the key right here. These middle terms are going to cancel out, and then minus x squared. So we have those middle terms canceling out, so we are left with x squared radical 3 minus x squared all over the square root of 9 is 3, so 3x squared minus x squared. 3x squared minus x, 3 minus 1 is 2x squared. So we have a 2x squared on bottom. And here in the numerator, I can factor out an x squared. X squared times the square root of 3 minus 1. My x squared and x squared cancel. So I'm left with the square root of 3 minus 1 all over 2. Square root of 3 minus 1 all over 2. Multiply by the conjugate, it's changing it from plus x to minus x. Plus x, its conjugate, just everything's the same except it's a minus sign. And then you FOIL it out like we were doing, and then simplify as far as you can. All right, here is the homework assignment. This is not going to be due on Friday. It will instead be due on Monday. This will be due on Monday. We will take questions over it on Friday, and we will work through a good chunk of these problems, any ones that you guys have questions on. All right, have a good day.